In class 12th physics, in capacitor topic, look at this higher thinking conceptual question. In this question, a circuit is given in which a capacitor of capacitance C is fully charged by a battery of potential difference V. Now the question is, if we insert dielectric between the plate of the capacitor keeping battery connected, then what will be the effect on the charge of the capacitor, potential difference across the plate of the capacitor, capacitance of the capacitor, electric field between the plate of the capacitor, and the electric energy stored in the capacitor. Now we solve this one by one. Can you solve it by yourself? First try and then watch my solution. First, we see the effect of the capacitance of the capacitor. Formula of the capacitance of the capacitor is epsilon R into epsilon naught A by D, where epsilon R is the dielectric constant of the dielectric between the plate. As epsilon naught A and D are constant in both cases, when there is no dielectric between the plate and when there is dielectric between the plate. Therefore, capacitance of the capacitor will be directly proportional to the dielectric constant of the dielectric. As dielectric constant of the dielectric is always greater than 1, therefore ratio of the capacitance of the capacitor in second case to the first case will be greater than 1. That means capacitance in second case after inserting the dielectric will be greater than initial case. It means capacitance will increase. Now we consider the second quantity, potential difference across the plate of the capacitor. As plate of the capacitor is directly connected with the battery, therefore potential difference will remain constant and will be equal to the potential difference of the battery. Now we consider the third quantity, charge on the capacitor. As Q equal to CV, V is constant, therefore Q will be proportional to C. As capacitance of the capacitor increasing, therefore charge on the capacitor will also increase. Now we consider next quantity, electric field between the plate of the capacitor. The electric field between the plate of the capacitor is given by the formula V by D. Now V is constant, D, which is the distance between the plate, is also constant, is not changing. Therefore, as V is constant and D is constant, the electric field will also be constant. Now the next quantity is electric energy stored in the capacitor. For this we use the formula in which one quantity is constant. We know that V is constant, therefore we use the formula half CV square. As V is constant, therefore we can write U proportional to C. As C increases, therefore U will also increase. Means energy stored between the plate of the capacitor will also increase. Now look at the second part of the same question. First, the capacitor is charged fully by the battery of potential difference V. Then circuit is broken by switching it off. And a dielectric is inserted between the plate of the capacitor. Now in this case again you have to calculate logically what will be the effect on this quantity when dielectric is inserted. So again we solve it one by one. In the first case, we have find out that C is proportional to epsilon R. And when dielectric is inserted, epsilon R will also increase. As any dielectric has dielectric constant greater than the vacuum. Therefore, dielectric constant increases means capacitance also increases. So the capacitance of the capacitor will increase. Now we consider the second quantity, charge on the capacitor. As battery is disconnected, therefore charge cannot flow from the battery to the capacitor or capacitor to the battery. Therefore charge will remain constant in this case. Now the next quantity is potential difference between the plate of the capacitor. The formula for the potential difference between the plate of the capacitor is Q by C. Here we know that charge is constant. It means V will be inversely proportional to C. As capacitance is increasing, therefore potential difference across the plate of the capacitor will decrease. Now the next quantity is electric field between the plate of the capacitor. The formula for the electric field is V by D, where V is the potential difference between the plate of the capacitor. As D, which is the distance between the plate of the capacitor, remain constant in both cases. Therefore, electric field will be directly proportional to the potential difference. As in third case, we have calculated that V is decreasing, therefore electric field will also decrease. Now the last quantity is energy stored between the plate of the capacitor. Again we use the formula in which one quantity must be constant. We know that Q is constant, therefore we use the formula U equal to half Q square by C. Now Q is constant, therefore U will be inversely proportional to C. As C is increasing, therefore U will be decreasing. Therefore, in this case, energy stored between the plate of the capacitor will decrease on inserting the dielectric between the plate of the capacitor. So, by this way, you can answer logically to all questions what will be the effect on this quantity if we insert dielectric between the plate of the capacitor.